I don't melt it over an open flame. A lot of people want to do that to keep the flame cranking. That's not the way to go with chocolate. The flame, especially back there, will come licking up around the side of your pot, heat up your bowl, and your bowl will be raging at 400 degrees, and it'll burn your chocolate.
Just like hollandaise.
Yeah, just like the hollandaise, if you've ever done hollandaise sauce. Hollandaise does the opposite thing. Chocolate separates and becomes oil and solids. Hollandaise curdles as hard as you get scrambled eggs. Either way, temperature control is extremely important. So what I do is I'll crank this up and get a good boil going, then I shut off the fire. Really shut it off. Let the steam do the work. I know it takes a few minutes longer, but it's worth it. Your chocolate will come out smooth, it'll come out melted, it won't have any lumps in it. It'll be nice if you take the time. Now that it's melted, we can't just use it the way it is. Chocolate will not harden at room temperature, really harden at room temperature by itself. It needs to be tempered first. The way we temper it is we're going to, first we've melted it. As you can see, I've raised the temperature up here to about 110, 120 degrees, get it melted. What that's done is it melted all the cocoa butter in the chocolate. Then we've got to chill it. We've got to bring it on down to about 84 degrees Fahrenheit. You'll notice I wrote melting up there, I wrote crystallizing down here. What it means is basically, as you cool it off, there's two main crystals in the fat that is being cooled. And one's called alpha crystals, the other's called beta crystals. Beta crystals are the first ones to crystallize. They'll start at about 88 degrees, and then 86 they really start forming. By 84 degrees, they're really setting up. They're starting to really crystallize. Once you get down to 84, the alpha crystals start to kick in. But already the beta crystals have started kicking in already, and they're going to dominate the chocolate if you've cooled it down sufficiently quickly. If you let it cool down slowly at room temperature, the alpha crystals will be the dominant, and that's why you saw this chocolate with all that powdery bloom all over it, because those are alpha crystals. If you cool it down slowly, that's what will happen. Our job is to find a way to cool it down rather rapidly so that the beta crystals take control of everything. Then, what we'll do after they've started to harden up is we're going to bring the temperature up slightly, just what we call the working temperature. That makes it more liquid and just makes it easier to work with. So you see I got a good boil going here. Off goes the fire. We'll put it on there, trap that heat inside, and the idea is just to keep the chocolate at a gentle warm temperature. Do you need a thermometer? Not really. Good chocolate, when it's heated and it's melted, it's going to be about the temperature of warm bath water. Good hot bath is about 105 to 110 degrees. 110 is really warm for a bath. But for chocolate, that's about perfect. If you get it up above 120, chances are it'll start to separate. Cocoa butter will start to separate out from the cocoa solids. And what you'll get is an oily pool with dark brown chocolate solids sort of floating around.
So what do you do at that point if you have no?
Throw it away. Yeah, it's no good anymore. The chocolate has to be brought together. The cocoa butter and the cocoa solids have to be brought together in the factory. And it has to be conched in a machine, what they call conching, which brings them together, marries them together with the sugar, and makes an emulsion. Once you've broken that emulsion, we don't have the equipment here to properly bring it together again. So you may as well throw it away. But if we're careful and we take a little bit of due diligence to be, take a little more time to do it, we'll never have to worry about that. Now that it's warm, we have to get that crystallization started. We've got to get that temperature to drop. So what I'm going to do is I'm going to add some seed to it. This is seed, just chocolate. It's already tempered, right? It comes from the factory that way. It's already tempered, and its beta crystals are the dominant crystal in here. If I pour it in here, and it's in with all this melted chocolate, it will start to melt as well. But as it's doing that, it's going to cool the chocolate, and it's also going to teach this chocolate what it wants to do. Believe it or not, it's like a trainer. It goes in there and trains the other, says beta crystals dominate, boom. Beta crystals chemically, physically, everything start to dominate the entire batch of chocolate. So we'll throw that in there. It's about 25% seed. There are other ways of tempering chocolate where you don't need to add a seed. I'll get to that next semester. We'll get into that in more depth. But the seed is the easiest way to do it. The chocolate now, we're going to just do one thing to it. We're going to agitate it. Time, temperature, and agitation. That's what chocolate needs. You gave it time already, right? You've already been heating it. You gave it some temperature. Now we're bringing the temperature down, but we also have to agitate it. Otherwise, the chocolate isn't properly mixed, and the alpha and beta crystals start to form pockets. They start to form little groups. Chocolate's very clicky, okay? It's like people sometimes. What will happen is the beta crystals will say, we're going to go hang out over here. Alpha crystals, we're going to go hang out over here. And what you'll notice is little swirls of cloudiness starting to form in your chocolate. That's the alpha crystals and their little cliques doing their thing. Right? The beta crystals are trying to dominate, and if you keep agitating, they will. As you cool it down, you're going to notice the chocolate getting thicker. It's going to start cooling down quite a bit. The way you test it to see if it's actually getting close is you put it on your forearm and see if the bowl is the same temperature as your arm. See if it feels warm to you, like you test a baby bottle, right? You put it on your forearm and it will tell you. It's a very sensitive part of your body. Right now it's about the same temperature as my arm, which means it's about 98 degrees. That's too warm. I need to get it down to 84 degrees. And 84 is going to feel noticeably cool to you. You ever get in a swimming pool that's 80 degrees?